The computer CPU directly accesses the memory to read and write data and execute programs. Because the read and write speed of the memory is fast enough. However, the memory is not large enough and the data disappears after the power is off, so it can only be accessed temporarily. In the end, a hard disk is needed for storage. Because the speed of the hard disk is not as fast as the speed of the CPU. Therefore, memory is needed as an intermediary. In addition, the CPU also needs to control the hard disk through the disk controller. We call this part of the work I/O, which is short for input/output. In fact, CPU with most external devices such as keyboard, mouse, network, etc. are all I/O. All need such a control process. Specifically, the CPU will notify the read data in the hard disk through the device controller. Then the hard disk and the memory transfer data. If the CPU is waiting, that is busy waiting, it will be a waste of time. So the CPU will switch to other processes. Then, when the I/O is over, the device controller needs to notify the CPU. This is called an interrupt. That is, let the CPU temporarily stop the current execution flow and turn to deal with I/O. In this video, we will start to talk about the interrupt mechanism in the operating system. The specific process of interruption is like this. First, assume that the CPU is executing other processes. At the same time, the device controller controls I/O devices such as hard disks and memory to transfer data. At this time, the transfer is completed, and the device controller sends an interrupt request to the interrupt controller through a specific bus. If the interrupt controller thinks it can be interrupted, it notifies the CPU, so the CPU blocks the current process and starts processing the interrupt. So how does the CPU handle it? When interrupted, the interrupt controller will place an address on the bus. It points to a table called interrupt vector. All of them are addresses, that is, pointers which point to the handles for different interrupt situations. For example, CPU does the aftermath work according to this processing program. Then, the process before the CPU is interrupted is executed line by line during execution. And the interrupt at this time is called a precise interrupt. That is, when it is interrupted, all the previous instructions are completed, but none of the following instructions have started. Correspondingly, it is a non-precision interrupt. Today's CPU has become very complicated. For example, the CPU uses pipeline internally. Multiple instructions will be in the CPU at the same time. When interrupted, the states corresponding to these instructions need to be saved. Okay, that's all for today's video. See you in the next issue.